So far we have divided a monomial by a monomial. So in the numerator and denominator both, we had just one term. But what if we have a polynomial, more than one term in the numerator, divided by a monomial in the denominator? We are essentially going to just do what we did that many times. So we see that we have three terms up in the numerator here. And so we're actually going to have three separate division processes. So the way that I like to teach this is look at each one separate. They all actually have a common denominator of 3x squared. So we can think about this as three separate division problems. So we have 3x to the 8th divided by 3x squared minus 6x over 3x squared. Note they're all over 3x squared, plus our final term in the numerator, x squared over 3x squared. And really from here, it's doing the same thing that you've been doing, because now these are all just monomial divided by monomial problems on their own. So taking a look at the first fraction here, we're going to look at our numbers out in front, our coefficients. 3 over 3 simplifies to just 1, so we don't need to really write anything there. And recall that we're going to subtract our exponents here. Our larger value is up top, 8, so that means our final x is going to be up top. So when we divide the numbers, we get a 1, which I'm not going to write, and then an x to the 6th. 8 minus 2 is 6. Now, that really just simplifies to x to the 6th. There's no more denominator since our final x is in the numerator. And when there's no denominator in a fraction anymore, we don't need to make it a fraction anymore. So this term simplified to x to the 6th. All right, minus, let's take a look at our next fraction here. 6 over 3. This can be simplified. We can divide them both by 3. We'll get a 2 and then a 1. A 2 and then a 1. So we have a 2 over a 1. Now we take a look at our exponents. There's really a 1 here in the numerator, but our larger number is in the denominator. So that means we start our subtraction down here and do 2 minus 1 for the x. And our x's are going to end up in the denominator because that's where the bigger one was. So 2 minus 1 gives us an exponent of 1. Then finally, our last fraction here, there is really a 1 out in front. If you wanted to put that there, it is 1x squared over 3x squared. And that means that we have a 1/3. That cannot be simplified anymore. So I'm going to leave it as a 1/3. And then let's take a look at our x's. When we do 2 minus 2, we get 0. That means we actually cancel out the variable in this problem. There's no more variable. Anytime we divide something by itself, which is what we're doing here, it completely goes away. So the x squareds completely cancel out. And writing this in the nicest way possible as a final answer, x to the 6th minus 2 over x. We don't need to write either of those ones there in that middle term, plus 1/3. I have one more example of this form. Here we again have a multi-termed polynomial in the numerator divided by a monomial, one term, but we just have multiple variables going on here rather than just x. We're going to deal with this in a very similar way. So we're going to break it up into actually two division problems now, two terms. So our first term in the numerator is 8x to the 5th. And then y to the 1st, and it's being divided by that common denominator of 2xy squared. And I'm putting in ones here for missing exponents when we can. It's going to help us solve. Then our second fraction is this next term also divided by that common denominator. So we'll do that one in red. So minus 2x to the 4th, y to the 3rd, divided by that common denominator, 2x to the 1st, y squared. Okay, now we're going to go through each one separately, as we have been doing. So in our blue fraction here, we have 8 over 2. Those can both be divided by 2 to simplify to 4 over 1. So we end up just having a 4 in the numerator and a 1 in the denominator. Next, let's look at our x's. Our larger exponent is in the numerator, so we'll start there and do 5 minus 1. So we will end up with x to the 5 minus 1, or x to the 4th, in the numerator. Lastly, our y's, the 2 is the larger exponent, so we'll start there and do our subtraction. 2 minus 1 is 1. We started in the denominator, so we'll end up there, y to the 2 minus 1, or y to the 1st there. So we have our first fraction done. Let's look at this fraction in red. 2 over 2 is going to simplify to 1 over 1. I'm actually not going to write any, I'll write it here because we'll simplify it. There we go. We'll see it. Okay, so we divided them both by 2. Then our x's, we can see our larger x is up here in the numerator, so we'll do 4 minus 1, and that will give us an x to the 3rd in the numerator. Then lastly, our y's, we're dividing y cubed divided by y squared, so we subtract 3 minus 2. We started from up top, so that's where we'll end up. 3 minus 2 is 1. Now, fully simplifying these, we don't need to write coefficients of 1, and we don't need to write exponents of 1. So our first fraction here, I don't need to write either of those 1s in the denominator. So we have 4x to the 4th over y as our first fraction. Here, I don't need to write those 1s. We'll just be left with x cubed y as our term. And there we have it. Nice job getting through part 1 of dividing polynomials.